This is Corey Glenn, and I'm going to show in this video how I go about making a shell denture so that I can have something that's really easy to use for a pickup conversion. This could be a full arch case like an all-on-4. Oftentimes those are very difficult to do the conversion on. Now if you've guided them ahead of time, you can go ahead and pre-design it, go ahead and make holes in it, but oftentimes people freehand these cases and you're left trying to convert a denture, and that's a very difficult task because you end up weakening the denture significantly. They tend to not hold up well. The temps will end up breaking right at one of the implant locations, and it's simply because there's not enough reinforcement internally. So I've shown a number of techniques using Trilor arch bars. That's still one of my favorite techniques. I wanted to show just a modification that can be used with Trilor or with what I'm going to show here, just of creating a shell denture so it's completely hollow on the internal surface, and that way it's very simple to punch the holes for your cylinders to pass through, and then you simply fill this up with bisacryl or acrylic or whatever your material of choice is. Put it over the cylinders and then let this set up, and it's quick and easy to finish and process. So let me show you how I would do this. First of all, you would need to go ahead and design a prosthesis. Now, the easiest and cheapest way to do this is just to use the Blue Sky Bio digital denture software. You can export the teeth and the gingiva all as one unit so that you've just got this massive horseshoe type temp, but it's going to be a solid object like this. And so what we want to do is create something that's completely hollow from the underside. So I'll show you how I do that. First thing I'm going to do is go into Mesh Mixer and use the Select tool, and then I'm going to just select the underside where I want to create the space for the cylinders to pass into. So just go all the way around, select it with your orange, and look at it from the side. Get this wherever you want it. You might not want to extend that far down, so you can push Shift and erase. And once you've got that, I like to smooth the boundary, so go to Modify, Smooth Boundary. We'll accept this, and now we have this orange selection. Now come back, just push Delete. So now you've essentially cut off the bottom of this, but this is not an object you could 3D print. This is something that is not a physical model at this point. It's just an outer mesh shell. So what I want to do now is, again, using the Select tool, double click this surface so it should select everything. And now I'm going to come up to Edit, Extrude, and we're going to extrude this internally. Now if you were to extrude this externally, it's going to grow your temp, screw your occlusion up. That's just not going to work. So rather what we're going to do is, when this extrude comes up, we are going to select an offset of -0.5. So we're going to extrude it negative by ½ millimeter, and in this drop down box where it says direction, you want to choose normal. And now let's accept that. And as you can see, we now have a physical object, so this is something that would be able to be 3D printed. We can clear this. The only thing you'll have to go back and tweak a little bit is these spikes that develop. That's just something that tends to always happen anytime you do the extrude function on something that's not a perfectly smooth surface. So just go to your Robust Smooth tool and just do a little once over running across this margin, and you'll see those spikes disappear. Okay, very easy. And let's look at this. So now we have a shell temp. I could now load that up into the 3D printer and print this. And what I would suggest you do is print this in something like NextDent Crown and Bridge, or NextDent MFH would be an even better option. I like the bleach shade. Bleach, it looks more natural, and you can stain it down with something like Optiglaze down to a darker color, but some of the other shades are not all that aesthetic. But this is going to be super easy now to fit our cylinders, because it should slot right over where your cylinders are emerging. You can punch the holes for them to protrude through. And now let me show you how we would do the pickup on that. So now we're ready to do the pickup. Now the first thing that I do is I would either make the reinforcement between the individual bars with Trilor. So I've shown that already. That's an excellent product you can get from Blue Sky Bio. That is composite reinforced fiberglass. Very easy to trim chair side. It is really, really strong. Here's another redneck method that you can do is just to take an old lab burr. So these are the stainless steel shank lab burrs that probably all of us have a million of lying around. And what I'm going to do is just heat this up over a flame and bend this. Okay, so you can see what I'm doing here is I've just heated this up in a flame, used a pair of needle nose pliers, and just bent this. And the goal is that I want to create something that is going to extend through the temporary, and that I can drop this shell temp over and it's going to reinforce everything. Now those of you outside of the US can do this with intraoral welding. If you've got intraoral welder available, then this shell temp is super easy. That's a great option. In the States, FDA, we don't have that option, and so this is another alternative. So how do I go about tacking this into place? I've got it roughly conformed to the shape of these. The product I like to use, since I can't intraoral tack weld this, is I'm going to use Primo Pattern. So Primo Pattern is a light curable pattern resin, and the reason I like this is because we are rigidly splinting these together, and that needs to be done very passively. I don't want to have to go back and section this because I'll be sacrificing the strength. So Primo Pattern has the lowest shrinkage of any material that I'm aware of. It's like under 1% if I'm not mistaken. So what I can do is just come in here, flow a tiny little bit. I don't want to take up all of this space in my little ribs here. I just want enough to tack this into place, and I'm joining these together. Essentially, I've made a verification jig right on this model in this case, but if you were doing this in a live surgery, this would just get done in the mouth. Being light cure, it's super quick and easy to do that. So let's pretend this was done in the mouth. We've now got this tacked into place, and now we're ready to go ahead and do the pickup. So you don't want acrylic or bisacryl going down into your surgical side. It'll wrap up in your sutures. So use some rubber dam, a glove, whatever, to create some separation. So what you can do is unscrew this whole assembly, lay it down on a piece of rubber dam or a glove, and circle or make little marks like I've done here of where those cylinders are going to emerge, and then use rubber dam punches to punch some little holes for the bottom of those cylinders to extend through, and then you can place it back into the mouth. One other thing you can see that I've done is I took two more small sections. These I just clipped with some tin snips, and I've added this in to go back the length of the distal extension. All right, so this is going to hopefully prevent this thing from breaking. This stainless steel is very, very strong in this 2mm dimension. Any place that I have two sections, I want to make sure that they're overlapping one another, because if I put it end to end, that creates a weak spot where it could break right between that. So here, everything overlaps. We've got something that is extending the whole length of the temp. And now this is what that would look like after you've put your cylinder bottoms into the holes that you punched. And now take your shell temp. So this is a 3D printed shell temp. You can see the whole inside is hollowed out. We didn't have to take their denture and grind the heck out of it. This was done for us very simply, and we just printed it out. Now put this in the mouth, start adjusting, opening up the holes for your cylinder chimneys to pass through. And once you've done that, now you're ready to do the pickup. Fill this with acrylic, bisacryl, whatever your material of choice is. I would suggest, since this is 0.5 mm dimension, I would suggest something clear or tooth colored so that you don't get the shine through of the pink on your teeth. But do your pickup. Seat this over, make sure you use your long screws with the multi-unit cylinders. And as you can see here, I used clear acrylic. Minimal damage was done to the temporary. And then you can go back and salt and pepper the underside, make sure it's cleansable, smooth, ovate everywhere. You're not going to have any areas that are food traps. And this is the finalized temporary. Now I've got this, and I physically cannot break this. I tried my hardest, I just simply couldn't do it, and that's because of the reinforcement of that metal internally. So this is a very strong temp option. Also, again, you can do that with Trilor. That's an excellent option as well. But the point is, the shell denture is what really makes this technique much more efficient. So I think if you made a few shell temps ahead of time, even if you break one, you're going to be fine, and it really will streamline your conversion of these full arch cases.